Are you ready to blast off into our final adventure into Newton's laws of motion?
Actually, rockets blasting off are a perfect demonstration of Newton's third law of motion.
But first, you know the drill. Pop quiz. Can you state Newton's first and second law of motion?
Yes, you can. We'll give you some time to think about it.
Newton's first law says that a body that is at rest will remain at rest, and a body in motion will remain in motion unless an external force acts on it.
Newton's second law states that a force applied on an object is equal to the object's mass multiplied by its acceleration.
Newton's third law is perhaps the easiest to remember. It states that for every action force, there's an equal and opposite reaction force.
It's basically an invisible handshake between forces.
Let's use our trusty ball to demonstrate. Take the ball at rest. As an object with mass, the ball exerts a downward action force on the ground. In response, the ground is creating an upward reaction force to push back on the ball. If there would be no reaction force pushing back, the ball would go straight through the ground. In fact, if the ground did not exert a reaction force, we wouldn't be able to walk freely without fear of falling through. The ground pushes back on us with every step we take. Another way to witness Newton's third law is when two objects collide. What happens when this ball hits the tree?
The ball is pushing against the tree with an action force, but the static tree pushes back with an equal and opposite reaction force, sending the ball off in another direction.
A really cool way to get to grips with Newton's third law is a rocket launch. Action and reaction forces are what's happening when a rocket lifts off. Let me show you. This is a water bottle rocket. You can easily make one at home with a plastic bottle and a bike pump. First, we partially fill the bottle with water. Then we pump air inside the water bottle until 3, 2, 1, lift off. Can you spot the action and reaction forces at play here? The pump is building up the air pressure inside the bottle. The compressed air really wants to escape, so it's creating the downward action force that eventually pushes the water out of the bottle. The reaction force is responding by pushing the bottle in the opposite direction, in this case, upwards, into the sky.
This is very similar to a real rocket lifting off into space, except that it uses chemical propellant instead of compressed air as a downward action force. In both cases, Newton's third law is essential for a successful liftoff.
We can almost always trace the interactions between objects, gases, and liquids back to action and reaction force pairs. These interactions can be as simple as placing a ball on the ground, or as complex as lifting a rocket into space. And that's it. Give yourselves a big pat on the back for diving into one of the most fundamental concepts in physics, Newton's laws of motion.
Let's recap to make sure it really lands home. Newton's first law says that a body that is at rest will remain at rest, and a body in motion will remain in motion until an external force acts on it.
Newton's second law states that a force applied on an object is equal to the object's mass multiplied by its acceleration.
And finally, Newton's third law states that for every action force, there's an equal and opposite reaction force. Thank you to ESA astronaut Samantha Christopher Reddy for demonstrating how Newton's laws are experienced in space.
For those of us here on Earth, get creative. Explore Newton's laws of motion with objects at home and at school. Remember to stay safe, have a blast, and set your curiosity in motion.
Bye-bye.